Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, minimum cost path. So what the problem is saying is we'll be given a square grid, okay? And each cell represents a cost, an integer cost that represents a cost to traverse through that path, okay, through that cell basically. Okay. So what we want to do is we need to find a path. We need to find a path from the top left cell to the bottom right cell by which the total cost incurred is minimum. Okay. So as the problem says, each cell represents an integer cost, and that basically represents a cost to traverse through that cell. Okay, so what the problem is saying is we want to find a path, okay, with minimum cost starting from top left to bottom right. Okay, so this is the ask. Okay, so I hope you have got the ask. Okay, so whenever there is a grid given, right, or a matrix given, okay, and we want to find a path, right, from top left to bottom right, and it's if it is minimum or a maximum, then in that case definitely BFS comes into the picture. Okay, this is a pattern, and where minimum or maximum is required, then we also in the BFS the normal queue won't suffice, but we would need priority queue. Okay, the priority queue. Okay, so using these two concepts, we can solve this problem. Okay. Now, first of all, let's quickly brush up the concept. What is priority queue, right? So priority queue represents the concept of minimum queue and maximum, min heap and max heap. Okay. So when we say min heap, so what it does is whenever, for example, whenever we ingest the elements in the priority queue in min heap order, right? So when we pluck out one element, so that is a minimum element. Okay. That is a minimum element which is returned from the priority queue. If it's a max heap priority queue, then if you pluck out an element, we'll get a maximum heap priority queue. Since we want to find the minimum cost, we are going to use minimum heap in the priority queue. Okay. So now, as you know, we are going to use BFS and priority queue to solve this problem. Basically BFS. Okay. So what we are going to do is we are going to have a distance matrix, basically a distance matrix. Okay, tracking the minimum cost. Okay, the path, basically the minimum cost of the path. Okay. So here what we are going to do is we are going to have a distance array of size same grid n into m, right? And we are going to initialize the distance array with integer max value. So you can say, so if you want to represent an infinity, then it will be definitely integer max value. Okay. So we'll initialize the distance array with or distance matrix or distance grid with this infinity. Okay. Now, since we have to start with this top left, right? Top left. So what we're going to do is, so consider here, we are going to, this is a priority queue. So what we're going to ingest in priority queue? So we are going to ingest the coordinates 0, 0, right? 0, 0, and the the cost, basically the cost in that cell. So we are ingesting into the priority queue. Just consider this a priority queue. And since we are starting with the top left, so we are going to initialize this with 9. Okay. That is the cost from where we are starting. Okay. Okay. So, okay. Now the other thing what they are saying is if we can go from any cell, we can go either to, for example, if we are on this cell, right? Either to top, right, bottom, or left. Okay, so there are 4 directions we can move. Okay, okay. Now since the priority queue we have this element, what we're going to do is what we're going to do is we are going to run a while loop until this priority queue is not empty. Okay, so first we're going to pop out the first element. Okay, so let's say the first element which we have popped out is 0, 0, 9. Okay, now as you know, we can move in 4 directions, but what are the valid directions basically for this particular cell? So one is right and one is bottom. Okay, so what we're going to do is we are going to compare, right, the cost of the current, right, of the current node plucked out, and and the cost of this particular cell on which we want to go, right, the cost of this particular cell. So what are you going to compare? If it is lesser than this particular distance, right? So what we are doing in order to go to this direction, in order to go to this cell, is it lesser than the current element at this particular position? Yes, definitely it is lesser. This is going to be lesser. So what we're going to do is we are going to update this, right? We are going to update with this 9 plus 4, 9 plus 4, 13, right? 9 plus 4, 13. And also we are going to add in the priority queue. So what is the position of this particular element, right? It is 0, comma 1, right? 0, comma 1, and the cost which is 13. So we are going to push in the priority queue. Okay, in the priority queue. Now we have another option to go down, right? To go down. So in order to go down, we're going to take the current distance 9 plus particular this. In order to go to this cell, what will be the, we'll need to add 6 here, right? And what is the value over here? It is infinity. Is it lesser? Yes, it is lesser. It is lesser. So what are we going to add? We are going to update this. Okay, we are going to update this to 15, and also we are going to add and also we are going to add this particular element, right? 1 0 15, right? So this is x coordinate, y coordinate, and the cost basically. Okay. Okay. Now we are done with this, right? We are done with like processing this particular node. Now what we are going to do? We are going to do the priority queue again, and we are going to pluck out the element with minimum cost, right? So which is the minimum cost? Here it is the minimum cost. Okay. So what it is? It is 0 comma 1 comma 13, right? 0 comma 1 comma 13. So it is this one, right? This one. So now from this particular, so this one meaning what? Here the corresponding cell is this one. Now from this cell, we can go, which are the valid directions here? We can go to the right, we can go to the bottom, we can go to the left as well. We can, yeah, we can go to the left as well, but not top. Top, it's not valid, right? So what we're going to do? So what we're going to do is, we are going to take the current distance plus, we are going to take the current distance plus this cell's distance, right? This cell's cost 13 plus 9, which gives us what? Which gives us 22, right? 22. Now we are going to check the corresponding position, right? At this particular, it is infinity. So 22 definitely is less than infinity. So we are going to update with 22. We are going to update with 22, and also we are going to add in the priority queue. Okay, we are going to add in the priority queue. Okay, so let's do that. Let's do that. So what is the position here? It is 0 comma 2, and what is the cost? It is 22. Okay, so this is intuition. So we are going to keep on doing this activity, okay, till we reach this one. Okay, till we complete activity till the priority queue is not empty. Okay, till the priority queue is not empty, and whatever after the priority queue is empty, so we are going to return whatever is the value of this n minus n minus 1, m minus 1. Okay, so this activity. Okay, I hope you have got the intuition. Now let's go to the code. I think you'll understand better. Okay, before going to the code, I'll request you to please subscribe to my channel, like the video. Okay, if you really got the solution, please don't forget to subscribe, as it will really be helpful to me. Okay, so first I'll show you the Java code followed by C++. Okay, so what we're going to do is, what we're going to do. So let's take first of all the length, right? Grid.length. Grid.length. Let's take, and what we'll take here? M 0.length. Okay. Then next, what we're going to do? We are going to take a priority queue. Okay. Priority queue, and we will need a custom object basically here. So what? So let's write a class for that. Static. Let's take it a node. Let's name it a node. Okay. So what we'll need? We'll need coordinates x, y, right? And then we are going to need a cost as well, right? Cost. And we'll need a constructor node int x, int y, int cost. Okay, what are we going to do? This dot x equal to x, this dot y equal to y, and this dot cost equal to cost, right? This dot cost equal to cost. So same we are going to have here the custom object or the node, right? It's the name of the custom object. It's node. Okay, pq new priority queue. Now what do we want? We want a minimum heap. Now minimum heap on what? Like on what parameter? We would need the minimum heap property on the cost parameter. Okay, so let's say these are the two objects of the node, right? Of the node type. Okay, now what we want to is, we want to have minimum heap or sort on the basis of the cost, right? This particular cost, right? So you want to create a minimum heap out of this particular cost. Okay, so whenever we are going to pluck out an element from the priority queue, so we are going to get the node with minimum cost. Okay, with minimum cost. So yeah, so here we have, then we'll also have a distance matrix. As I said, distance equal to new int n and m, right? M, right? And then we are going to initialize this, right? Int I equal to 0, I less than n plus I, Similarly, let's have this int j equal to 0, j less than m, and plus plus j. Okay. Then what are we going to do? Distance of ij, we are going to initialize with infinity, which is integer dot max value. Okay. Integer dot max value. And now what are we going to do? Since we are starting with the top left element, so distance of 0, 0, we are going to initialize with grid of 0, 0. So as I said, right, grid of 0, 0. Grid of 0, 0. So what, so here you saw, right? So we distance of 0, 0, we initialize with grid of 0, 0. So that's what we did here. Now what we are going to do? We are also going to add in the priority queue, new node, right? We are starting with the top left 0, 0 and grid of 0, 0. The cost basically to start from the 0th x and 0th y. Okay. So here the node has been added. Now what we're going to do? We are going to run a while loop. Is empty, right? Also, in order to move into 4 directions, what are we going to do? What we are going to do? We are going to have, let's say, uh, 2 distance array dx, for example. So what does this mean? -1, 0, 1, 0. I'll let you know what does this mean, and dy, right? In order to move into 4 directions, we want to have these 2 arrays. So -1, 0, 1, 0, and -1. So what does this mean? So dx -1 means to the previous row. Okay, and the same column, previous row. That is top. Okay, this one means the row is same, but we are incrementing the column. This means right. Okay, this particular means bottom, the row, the next row and the same column. And this particular means the same row and the left basically to the previous column. So, okay. So what are we going to do now? Now we are going to first pop out the minimum node with the cost. Okay. Cur equal to pq dot poll. It will pluck out the minimum, the node with minimum cost. Okay. Now what are we going to do? We are going to run a while loop, sorry, a for loop to run into 4 directions, right? To run into 4 directions, plus plus I. Okay. Now what we're going to do is we are going to have a neighbor, right? Neighbor coordinates. NBRX, the neighbor coordinates. How it is going to be? So cur, so this is going to be what? Cur dot x plus dx of plus dx of I, right? So how it is, for example, right? So cur dot x, for example, cur dot x, if it is 0, if it is, sorry, cur dot x, if it is 0, right? So this particular cur dot x. So what is the distance? What is the coordinates of this particular node? 0, comma 0, right? So cur dot x, if it is 0 plus dx. What is dx of 0 here? Dx of 0 is -1. Dx of 0 is -1, right? So what we are doing, 0 minus 1, which is going to give us -1 here, right? -1. And dy of 0. So 0 plus what dy of 0 mean? Dy of 0 here means what? It means 0, right? Dy of 0, it's 0. So 0. So what we have? We have 2 coordinates, neighbor coordinates 0 and -1. -1 and 0. So we are going to check if it is valid. Definitely -1, it is not valid. So so what we are doing? We are checking the 4 possible directions here. Okay, 4 possible directions here. So nbr y, cur dot y plus dy of I, right? Now we're going to check if these neighbor coordinates, if these are valid, then only there's a point to move ahead, right? NBR x, NBR y, n, and m. Okay, we'll check, we'll implement this function later on. Okay. Now, if it is valid, so what we're going to do is we're going to now check if cur dot cost, okay, plus if cur dot cost plus grid of NBR x and grid of NBR, sorry, NBR y, right? NBR y. If it is less than distance of NBR x and distance of NBR y, okay, NBR y. So what we are saying here is, for example, let's say initially, right, what was a 009 we had pushed in the into the priority queue, right? In this particular priority queue. If this is a current dot cost, if this is a current cost, right? And in order to go to this particular cell, right? So what are we going to do? So what we are checking, 9 plus this grid of neighbor xy. Okay, this is neighbor xy. 4, 9 plus 4. If it is lesser than this particular distance, infinity. If it is this lesser than this particular distance, yes, it is lesser. Then we are going to update this particular cell into the distance. Okay. So yes, it is lesser, definitely. So what are we going to do? So distance of NBR X, NBR Y equal to, so we are updating this, and also we are going to add. We are going to add into the priority queue. Okay, node NBR X, NBR X, and NBR Y. Okay, NBR Y and distance of whatever is updated one, right? Whatever is updated cost, right? NBR X and NBR Y. NBR Y. Okay. So in this way, we are going to go till this priority queue is not empty, and finally we are going to have into the distance n minus 1 the shortest, the minimum path, basically the minimum path to traverse from the top left to the bottom right. Okay, so let's compile this. Let's see if it is working. Oh, we didn't implement valid, right? So we want to implement valid, this particular function, right? Valid. So we want to check whether the coordinates are valid. So what we're going to do, boolean valid int x, int y, int n, int m. Okay, and what we're going to check, return x should be greater than equal to 0, and y should be y should be greater than equal to 0 in order for the coordinates to be valid, right? So x should be less than n and y should be less than m, right? So if it matches this condition, then the coordinates are valid. Okay, let's compile it. Let's see if it gets compiled. Again, we have some issue here. What is the issue? Distance of, oh, some issue here. Typo. Let's compile. Again, here is the typo again. I think this should be good now. Let's see. What is it? Yes, it's compiled successfully. Let's submit it. I hope you have got the solution. Please don't forget to subscribe the channel, like the video. Okay. The test cases are being processed. Yeah, the test cases are processed. Okay, please subscribe to my channel, like the video. I hope you have got the solution. Let's quickly see the C++ code as well. So here's the C++ code. Okay, so we have the custom class, right? And here we are initializing x, y. Okay, then we have what? This is the compare, the sorting logic here, right? A dot distance. Basically, distance is what? It's nothing but cost. It's nothing but cost. So distance is nothing but cost over here. And then, as I said, this is the comparison, right? The comparison operator function. Okay. In order to have our mean heap property in the priority queue. Okay. So what we're doing here is we are taking the size of the n and m, right? And then we are having this distance matrix, right? Distance matrix. We are initializing with what? Int max, right? Which is infinity. And then here we are initializing the priority queue, and we are calling this compare, right? Compare function. Okay, to have the minimum heap priority queue. Okay, so here we are having our two arrays dx and dy in order to move into 4 directions. What we are doing here is we are initializing the distance of 0, 0 with the top left element, right? The top left cost, and also we are adding the node or the custom object into this priority queue with coordinate 0, 0 as we are starting with top left, and the cost, right? The starting cost, the top left cost. Okay. So we are going to iterate through this priority queue. We're going to pop out, right? We're going to pop out the minimum, the node or the custom object with minimum cost, right? And then we are going to move into 4 directions. We're going to check NBR X and NBR Y if it is valid. If it is valid, then we're going to check if the current distance, if the current cost plus the cost to go to the neighbor element, the cost to go to the neighbor element, if it is, here we are checking the current cost plus the cost to go to the neighboring node, right? The cost to go to the neighboring cell. So if it is lesser than distance of that particular NBX already, then we are going to update. Then we are going to update the minimum cost, right? The minimum cost, and we are going to add into the priority queue. So in this way, we will reach once we are exhausted, right? Once the priority is empty, so we'll have the minimum cost here for to go to the bottom right. Okay, to go to the bottom right cell. Okay, so this is a solution. I hope you have got the solution. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.